All right, in this example, we're looking at synthetic substitution. So we can use synthetic substitution to evaluate the polynomial. In a previous example, we looked at a polynomial and we evaluated by just plugging in the number and figuring out what it evaluated to. We can also use something called synthetic substitution to do the exact same thing. So I'm going to do this for number 6 right here. And we're trying to figure out, what if we plug in x equals 2 into the function? What's the result of that? So in order to use synthetic substitution, we're going to take the number that we're going to plug in 2, and we're going to write it over on this side. Then we're going to kind of make a box here. I'm just going to write kind of a line that separates this and put a line over. And then what we're going to do is take the polynomial here, and we're just going to write the coefficients. We're not going to write the whole thing. We're just going to write the coefficients in order on the right hand side. So I'm going to take, I'm going to write this as 5, 3, -1, and 7. It's important to realize here that if you have a term that's not represented in there, like number 7 is the x squared is not represented, that you have to still plug in or represent that coefficient in the problem. So for number 7, you can see the x squared is not in that problem. You're still going to have to put in there a 0 for x squared when you do this process. All right, so going back to this, so we take the number, we put it over here, and then we take the coefficients of the function and put them over here. And what we do now is we take the leading number and we just basically bring it down, and we're going to put it on the bottom here. It's kind of like, take the first number and just kind of bring it down. Then what we're going to do is we're going to take this number and multiply it by that number right there. So we're going to say 2 times 5. So 2 times 5 is 10, and I'm going to put it in the next column. So I'm going to put a 10 here. And then all I'm going to do is start adding these columns as I work to the right. So then I'm going to say, all right, well, what's 3 plus 10? All right, well, that's 13. So then I write a 13 down there. And then I'm going to multiply again, and I'm going to say, all right, 2 times 13. What's 2 times 13? Well, that's going to be 26. So now I take the 26 and I write it in the next column. And then I just do the same thing. I go ahead and I add this again. So I say -1 plus 26. Well, that's 25. And then I multiply again. I keep multiplying by this 2. So I say, what's 2 times 25? Well, that's going to be 50. So I'm going to put a 50 here. And then I'm going to add up again. So I'm going to get 57. And since I'm all the way done, I'm going to stop right there. And this number right here should be my answer to the problem. All right, so if I plug in 2 into this function, it should be 57. I'm going to check the answer, and the answer is 57. So our final statement could look like, our final statement would look like this: f of 2 is equal to 57. So this you might be asking yourself the question, why would I use synthetic substitution? What's the point of that when I can just plug it in, just use direct substitution and get the same answer? Once we get into further sections, we're going to use the same process, the same algorithm, that's this synthetic algorithm, to do a lot of other things. We can do something called synthetic division, and so it's good practice here because we're going to be using it later on. And actually, once you get used to it, it's a pretty quick way to do things. It takes fewer steps than the direct substitution once you get used to it. So give it a try. Try number 7. Take 7, try it, pause the video, and then we'll go over it. All right, so how do we do number 7? We have g of x equals that polynomial. We're going to plug in -1. So I'm going to put -1 off to the side here. Then I'm going to create this little box here. I'm going to put the coefficients on the right. So -2, -1. Now here's the trick. There is no quadratic term represented there. Even though it's still there, it's just 0x squared. So the coefficient is 0. We still have to put that 0 in for that x squared problem, even though it's not actually visual. Then I'm going to have 4, and I'm going to have -5. So now we do the same process. We're going to kind of bring down that -2 and basically start multiplying and then adding. So -1 times -2 is 2. I'm going to add to get 1. This becomes -1 because I'm going to multiply. And then I'm going to add to get -1. -1 times -1 is 1. I'm going to add to get 5. And then -1 times 5 is -5. And I'm going to add to get -10. The last number that we get should be our answer to the problem. So g of -1 is equal to -10 is what you should have got. And if I go check our answer over here, you can see that the answer was -10.